Hello, welcome to my poster presentation regarding bridging JMP and Python for seamless and engaging analysis. My name is Jarmo Hirvonen and I work for Murata in Finland. In this poster, I will explain why you should utilize Python in JMP or Python integration in JMP, some things to note regarding the integration, and one of the applications we have developed here at Murata, Finland, me and my colleague Eero, that utilizes the integration. Let's start with the why to utilize this capability in JMP. JMP is a very visual and interactive tool with good analytical capabilities. On the other hand, Python is basically the de facto programming language for many data-related tasks. It has many very well-established libraries, and it's possible that your company even have their own capabilities in Python. I see this from two points of view. We have JMP first users who will get access to features that are not natively available in JMP, such as some machine learning models, Torch, it's one example, and then access to file types you couldn't otherwise use in JMP. One example from that is Parquet files, so you can open them in Python and then bring them through the integration to JMP. And then for Python first users, they get access to JMP's visual and interactive tools that they can utilize then either directly in JMP or then in some sort of integrated way from the Python side. Of course, there are also some analytical capabilities that you can only find from JMP. And then things to note regarding this integration between JMP and Python. Python is installed with JMP 18, that's one thing. It is a bit slow on initial load per JMP instance. So meaning that when you first load it in a JMP instance, it takes some time, but on the next load, if you don't close JMP fully, it's faster. It can be, you might have to take this account if you are just doing something very small. It might be worth trying to do it in just JS, it's faster. Package management and installation can sometimes cause some problems, but there is some documentation regarding it, and sometimes it can be a bit of a hassle to solve. You have only one environment, so if you are used to working with virtual environments, you cannot currently do it in JMP integration. You have to understand on some level the JSL and Python data type conversions, but there's a documentation on JMP webpage regarding these. Scoping can be confusing, or it is a bit confusing. The Python is basically on global scope, and depending how you name your variables, they can get a bit tangled between different scripts and so on. And then finally, in my opinion, maybe one of the biggest things here is that Python debugging and development can be a bit annoying experience, and it can be difficult to get into a flow. And this is mostly because you cannot reset the Python in JMP or restart the kernel. And you end up in this type of, in quotes, cycle of the development. You develop in Python, then you want to test it, and you suspect that there's something that you would want to clean from some variables, for example. Only way to do it currently is to close the JMP instance, rerun the JMPs, then load everything back, and then you can test the code. So this is not a cycle, it basically breaks here, and you have to restart the whole thing again from start. So it breaks a flow. Can cause a frustration. You can mitigate this a little bit depending on how you write your Python code. And then to our application. So what is JMPyFacade? First, the name comes from the way facade, that it facades basically the complicated JMP and Python code behind fairly familiar JMP-like user interface. It is version-controlled add-in, which gives JMP users access to Python capabilities that have been predetermined. We call these services. And these range from very simple dataset creations to much more complicated anomaly detection or machine learning models. What we want to do with this is to give access to our JMP users to utilize Python capabilities without them basically knowing that they are using Python at all. We did have something a bit similar earlier, but in that case, we utilized server to bypass JMP's Python integration because earlier it was a bit difficult to use. But now with JMP 18, we can use the native integration and it works pretty well. And then flow of the application, when user runs it, they run the add-in, then it will check if it's updated or not. If it's not updated, it will get update and user will rerun the add-in. If there's no updates to be found, it will initialize Python in JMP. And purpose of this step is to basically create the app data folders. If user hasn't run it, you could run in something application like this into some problems if they do not exist. After we have those initialized, we run a check from our package management if there are packages that should be updated. If we update them, if necessary, and if nothing to update, then we just continue. We check if user has a table open, and if there's a no table, we will close the add-in and inform user that check, open a table before running this. This is done currently because we only support one single static table, basically. And then when user has a table open they want to analyze, then we import the packages. And if there's an issue, again, it's a stop and then showing log what went wrong. If it's successful, we initialize the user interface, create the user interface, and users can start using the tool. If the user interface does already exist in the JMP instance, we will just bring it to front and we do not re-initialize anything. A little bit how it works in the background. We are utilizing data types, JMP classes, and then on Python side also PyDante package to create the models we use, and for type validation and data validation. Here we have an example of HTTP scan. And if we take, for example, this features argument here, it's a list of strings. It's a field which has minimum length of 1 and utilizes JSON schema, which are numerical columns. When JMP gets this, it knows to create this type of class. So we have a button, column list box. User has to input single numeric, at least a single numeric column here for this to work. And different type of element for different types of data, integers, numeric boxes, and then we have booleans, which are checkboxes, and so on. When user is ready to run the service, they fill in the columns, click the run service button, and at this point, the JMP side of the code will create a subset of the data with just these columns and take the columns which are not excluded. And these are then used when the Python function is called. Makes it a bit easier to manage on the Python side. That's why we do it like this. Python will run its algorithm and it will update the values to the subset. And when the Python returns some values, JMP knows, okay, now we can update the original table. It will update the table, close the subset, and then also create some table scripts and column properties to the original table. And every time user runs basically a service, it will create new columns to the table if there are columns to be created. And then a few examples of the usage. This is a basic example. So user runs the add-in, it checks from the version control. And in this case, user wants to run TSNE from this add-in. So they select the TSNE from the left side, input the columns, and they also check from the documentation. This is official documentation from the TSNE. If they, for example, want to know how it works, what it does, and what the parameters are. When user is ready to run the service, they click the run service button, and new columns are created to JMP table. And now they could just work with those like they normally would in JMP. And then we also view the report script. In this case, it's just the input parameters. And here a bit more complicated examples or excessive examples or expansive examples. In this demonstration, it's an interactive mode. In my opinion, one of the best features we have here. So these do not create always new columns. They update static columns and they immediately rerun the algorithms, Python algorithms, when user changes any values in the user interface. So for example, you can use this exploit data analysis or fine-tuning algorithms. So here, user basically clicks up arrow on the keyboard and it will rerun the Python algorithm all the time. And the clustering will change based on that when user updates the values. More obvious here when the components change. So you will get totally different clusters depending on the values you have. So you could modify values here interactively, figure out what are the best in this case, and then maybe go back to Python and use these there, for example. And then we have this feature importance service that utilizes multiple algorithms and then uses Shapley values to determine which could be the most important for modeling or predicting something. So we run the models, we get Shapley graphs back, and then also ranking of our selected algorithms. In this case, LightGBM, XGBoost, and AdaBoost. And from here, user could basically copy-paste the values from here and then start modeling in JMP using these columns. And then finally, some future work for this tool, adding support for the dynamic table. Now we have the one static table, more services, image analysis, and our own custom machine learning models. Improves the interactivity, so Python would basically create graphic scripts or update graphic scripts directly. Exporting and importing Python models, utilizing JMP's great DOE capabilities for parameter fine-tuning, creating pipelines so you could run multiple services in a sequence, improve the dynamic features we have here, and then depending what JMP 19 brings, some possible refactoring so we can further improve the tool. And then some things to discuss maybe is open sourcing this so there could be more than just us two developing this tool. Thank you.